gas. And methane is CH4. It's an organic substance because it's got carbon in it. And I want to burn it. When you burn something, you're combining it with oxygen. So if we're just talking about the oxygen in the air, what do we know about oxygen? Monatomic, diatomic? Diatomic. And that's going to be the gaseous state. And when you burn what's called a hydrocarbon, you see where that term comes from? Hydrocarbon, hydrogen and carbon. You hear about that all the time on the news. Hydrocarbons, butane, propane, all those different things. Those are hydrocarbons. If you burn it with enough oxygen to go around, you're going to get carbon dioxide gas. If you burn it and you don't have enough oxygen around, you'll get carbon monoxide gas, of course very toxic, and that's why you don't want a closed up little fire, you know, in your house or something where the oxygen could all be used up, or a gas heating thing. It's always problematic. So, you want to have plenty of oxygen so you get this gas and not carbon monoxide. And, let's see, the other thing we're going to get here is water. Now the water could be in the gaseous state, or depending upon experimental conditions, it could be in the liquid state. Everything that's over on this side of the arrow, those are referred to as reactants. Sometimes you hear them called reagents, but reactants. Everything to the left of the arrow. See, this is just shorthand for a big long sentence. The big long sentence would go, methane reacts with oxygen to give us carbon dioxide and water. But we want it in symbols here. Okay, so everything over here is reactant. There may be one reactant, there may be a half a dozen reactants. It doesn't matter. It just depends on what reaction we're talking about. Now, all reactants are to the left of the arrow, but these things can be written either way. It doesn't matter a bit who comes first. Okay, over here, everything over here is a product. There may be one product, there could be a half a dozen products or more. Again, all products have to be to the right of the arrow, but it doesn't matter which I put first. I can put the water first, or I can put the carbon dioxide first. Doesn't matter at all. Now that is our starting point for the problems in section 3-1. You will be given all the reactants, you will be given all of the products. Now, your task is to balance this thing. Okay, when you balance it, what we're at liberty to do is we play with coefficients. We never, ever, ever touch a subscript. And of course, these guys are the subscripts. Those are set in stone. So what we want to do, we're going to come up with the correct coefficients. And just so everybody gets the same answer, good form is the lowest whole numbers possible. Everybody catch that? Lowest whole numbers possible. So that everybody's going to get the same answer. Okay, so I look at this, and what I do is I look for a trouble spot. Okay, now, I'm just glancing through it. I see one carbon over here, and I see one carbon over there. That is not a trouble spot right now. Okay, if I look at the hydrogens, I say, well, I have 4 hydrogens now here, but I come over here and I only have 2. That is a trouble spot. So let's start there. And there's no one right way of working these. You try one thing, you try something else. I will tell you though, even though oxygen is a trouble spot, do not start there, because it will bring you misery. Because the oxygen does not all end up in one spot. And so as we start, let's look for a trouble spot. It's only one time on the left and one time on the right. Okay, so I got 4 of these guys here. I come over here and I got to fix this up. So, Nicole, what do I need to put in front of my water?
2.
A 2. Now, when you put a 2 there, it dictates your next move. So I come back over to here, and Nicole, what does this have to be then?
2.
But if you put a 2, you just jacked your oxygen or hydrogens up to 8, so you need a 1. Now, you can make an argument, chemists are too lazy to write 1s, and yeah, that's true, and if you left nothing there, it's understood to be a 1. I would highly advise, put that one there because it shows us we've been there, we've thought about it, don't screw around with it again, yet. Okay, so it just shows us we've been there. We just took care of the hydrogens. Now, when we put this one here, that also set the carbon. See, that dictates your next move. So I look at my carbons there, I look at my carbons right here. Timothy, what do I want here?
1.
A 1. And again, if you leave it out, it's understood to be a 1, but I would not do that. I would put it in for safety. All we have to do is work through our oxygens, the one that was going to be the hardest. So you look at how many oxygens you have here, how many oxygens you have here, and what is that grand total? Somebody just shout it out for me. 4. So, Hina, I come back over here and what do I do?
2.
A 2. Okay, now let's check. If you have the luxury of time, you should never miss one of these. I mean, if you have time enough to go back and forth, because you've got this wonderful way to check it. You say, 1 carbon, 1 carbon, check. Okay, 4 hydrogens, 4 hydrogens, check. Okay, 4 oxygens, 2 here, 2 more here, 4 oxygens, fine. Okay, now, technically, of course, if you don't write this down, if you add those numbers, technically you are balanced, but it's not good form. It's not acceptable. And so what you want is the lowest whole numbers possible. We do not want to do it that way. It's like a language. I can say, I ain't going to give you a nice test. Okay? Well, that conveys the idea, but that's not very good grammar. I should say instead, I'm going to give you a horrible test. Okay? Nobody's going to pass it. No, you don't want to hear that. But see, you can say things in any language in, you know, good ways, and of course that particular example, no way is a good way. But you get the idea that we want to use the best form we can. So lowest whole number ratio. So let's get rid of that. And there's our answer. Now, how will this be asked on a test? Here's one possibility. You got the bare bones, all the reactants, all the products, and the test question is, what is the sum of the coefficients from the balanced equation? Let me say it again. What is the sum of the coefficients from the balanced equation? Now that means all coefficients. Can anybody give me a number?
6.
6. Okay, because 1 and 2 gives you 3, 1 more gives you 4, and 2 more gives us 6. Now you say, that's not chemistry, why would they ever do that? Because the test writer is lazy. Okay, because what does it make you do? You have to do all the work, but the person writing a multiple choice test does not have to type up 5 little equations, one of which is right and the others have some obvious mistakes. It makes you do all the work. Now, if you're an attorney in training, you might think, well, what if I had these 2 inverted and it really wasn't balanced? Well, lucky you, you would still get the right answer. So what we're trying to do is find a way, and standardized tests, if you have PCAT or MCAT or any of those things in your future, standardized tests almost always ask it that way. Give me the sum. That's another really strong argument. Write those ones down, so that if you're doing a sum, you won't forget them. Now, another way it could be asked, in the balanced equation, what is the coefficient for water? And you all would shout, 2. Okay, or what is the coefficient of the oxygen? 2. And it does not mean, go around and think about these oxygens, it means the oxygen. So the coefficient's 2. Okay, did we survive that first one okay? All right.